Hey guys, Ms. Subin here, and today we're going to be talking about exponents and specifically product of powers, which basically means we multiply exponential expressions together. Today we will multiply bases with exponents together to solve the problem. So for our vocabulary, just a reminder, when I'm talking about the base, I'm talking about numbers like 7 that are like a full-size number, and numbers like 4 are the exponent. So base and exponent are the two words that you need to know today. Product of power. So when we're talking about product of power, we're multiplying two or more numbers with the same base with exponents. So here you can see we have a base of 8 on both of these values, but we have different exponents. What we want to do is we're going to actually expand this so that we can actually consolidate or make a smaller answer. Our goal is one base, one exponent. So we're going to solve the following problem. 8 squared times 8 to the third. Now, I don't really care about the value. We just want to rewrite this so it's just 8 to the something instead of having two 8 to the something being multiplied together. So the first thing I always like to do is expand the problem. So for our expanded form, I'm going to start with rewriting 8 squared as 8 times 8. We're then multiplying that with 8 to the third, which is 8 times 8 times 8. So 8 squared times 8 to the third can be written like this, or it can be expanded. Both of these expressions have the same value. Now, we haven't gotten to our goal yet. Our final answer we want to write as in simplified form, so a single base with a single exponent. Well, our base is going to stay the same the whole time. Our base in the original problem was 8. And then for our new exponent, we just want to count up how many total 8s we have in the problem. So now that we have it written out, it's easy to count. 1, 2, 3, 4, 5. Our final answer is 8 to the fifth. 8 squared times 8 to the third has the same value as 8 to the fifth. The reason we do this is so that we can look at an expression and write it in a simpler way, so it's easier to understand. So let's do another one. Here we have 4 to the fourth times 4 to the third. Now, this is already an exponential expression because there's exponents, but we want to make it so there's just one base and one exponent. Because they both have the same base of 4, we can do this very easily. First, I'm going to rewrite 4 to the fourth power, which is 4 times 4 times 4 times 4. And we're multiplying that with 4 to the third power, which is 4 times 4 times 4. Now that we have it expanded, it will be very easy to count up how many total we have. Our base still is 4, but now we just have to count up how many total 4s we have in our expanded form. 1, 2, 3, 4, 5, 6, 7. So 4 to the fourth times 4 to the third is the same as 4 to the seventh. This one's a little bit more complicated just because there's more of it, but it's the same idea. We have 3 to the fourth times 3 to the eighth times 3 to the third. The reason we can simplify this is because all 3 of our pieces had the same base of 3. So what I'm going to do is I'm going to go ahead and write this in expanded form. So I have 3 to the fourth, which is 3 times 3 times 3 times 3, sorry, it's 3 to the fourth, so we need 4 3s, which is being multiplied with 3 to the eighth, so 1, 2, 3, 4, 5, 6, 7, 8, which is also being multiplied with 3 to the third. So 1, 2, 3. Now, some of you may have figured out a shortcut at this point, but I don't want you to memorize rules. I want you to memorize how we get our answers. I want you to understand how we get our answers, not memorize. So for this one, now that we've written out 3 to the 4th, 3 to the 8th, and 3 to the 3rd, and they're all being multiplied together, let's count how many total we have. So our base on our answer is still going to be 3, but we have to figure out 3 is being multiplied how many times total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 total times. So 3 to the 4th times 3 to the 8th times 3 to the 3rd is the same as 3 to the 15th power. This can also be done when we do not know the value of our base. Here we have a variable, b. We don't know what b is equal to, but we know that we're going to be multiplying b 4 times for b to the 4th and multiplying b 2 more times for b to the 2nd. We are going to be writing out our expanded form for each of them today, just so we can get it in our head what expanded form is and how we can get the simplified form from it. So b to the 4th, we have b times b times b times b being multiplied with b squared. Even though I don't know what b is, in the simplified form, my base is still going to be b. We can be more specific if the problem ever tells us what b is equal to. In this case, it could be anything. Then we just have to count up how many b's are being multiplied. 1, 2, 3, 4, 5, 6. So we have b to the 6th power. So b to the 4th times b squared is going to be b to the 6th. Example 4, something strange is happening here. We have 9 to the 0 power. Now recall your power of 0 rule. Any number to the 0 power is the same as taking that number and dividing it away. 9 divided by 9 is equal to 1. So 9 to the 0, we actually don't have to write that one at all because multiplying by 1 does not change the value. So for this one, we just have 9 to the 8th, which would be 9 times 2, 3, 4, 5, 6, 7, 8. And for this one, our final answer is just going to be the 9 to the 8th. 9 to the 0 power is equal to 1, so it doesn't change the value of 9 to the 8th. So whenever you see 9 to the 0 power, you can kind of just ignore that part of the problem. Here we have one final example. So for this one, we have 2 to the 1st times 2 to the 3rd times 2 squared. So for this one, 2 to the 1st is just going to be 2 times 2 to the 3rd times 2 to the 2nd. Again, we just want to go through and count up how many 2's are being multiplied. So here I have 1, 2, 3, 4, 5, 6. 2 to the 6th power. Now I'm curious to see if any of you have figured out a shortcut for these problems. If you think you found a shortcut, let me know in the chat. Send me a private message and maybe I'll come up with some kind of way to reward you for that. But at this point, you can go ahead and get started with today's activity.